Good morning, everyone. Today we are going to start a new topic, the nature of light, or we call it light and matters. To give you a basic insight of the topic, I can tell you that at the moment, scientists uh, discovered that light sometimes behave like waves and sometimes they behave like particles. So in this case, then we have the particle model of light and the wave model of light. So no one knows what exactly is light. It is not a particle, it is not a wave. It just sometimes behave like particles and sometimes behave like waves. So in order to understand the whole concept, we are going to start um, revising what we learned in year 11 first, which is the property of waves. Let me show you a wave. A wave can be easily generated with a string. So if I have a string lying like this, and I give a pulse, then I have a wave. If I continuously moving it up and down, then you have a perfect sine wave like that. Now, this is a transverse wave, and if light behave like waves, they're going to behave like a transverse wave. When looking at this wave, we can easily sketch it as a sine graph. Now, just let me show you how we sketch waves. There are two ways to sketch a wave on a sine graph. Now, the number one way is we have amplitude on the y-axis, and we have the length on the horizontal axis. So then we sketch a sine wave. Now, in this diagram, obviously, what's happening is we have the amplitude of the wave. So if it's a sound wave, the amplitude tells us the sound intensity of the wave. If it's a light wave, the amplitude tells us the light intensity of the wave. So just remember we have the amplitude, and then we will have wavelength according to this. So this is a period of wavelength. And the symbol for it is Greek alphabet, lambda. Okay. So whenever you say lambda, we are going to talk about the wavelength. Now, here, now the other way to sketch the wave will be similar, but very differently. Okay. On the other graph of the same wave, just remember I am sketching the same wave. Okay. I have the amplitude as the y-axis. On the x-axis, I have time. Again, I will have a sine wave. Okay. So a wave can be sketched in two ways. Now, in this case, okay, the distance on the x-axis of the second diagram here will be the time taken for one period of wave. Okay? So here, this point here is basically the period measured in seconds. Okay. Yep. So if we look at this wave again, okay, we can either sketch the shape of the wave, okay, over the horizontal length, or we can look at any particular points. For instance, if I look at this point here, okay, when I play it, you see that the particle move up, move down, move up, and move down over a period of time. This is when we sketch the wave, okay, regarding its amplitude and time. Okay. So both graphs can be describing the same wave, but gives us different information. Now, the other thing we need to be clear is about the period. The period is measured in seconds, okay, and also, okay, we have something called the frequency. Okay. Frequency is measured in hertz. It means how many period is passing through a certain point in 1 second. So for instance, if you look at this point again, when we have the wave, okay, frequency is how many times does that point vibrating, okay, in a circle in over 1 second. Okay, it's measured in hertz, and period and hertz both measures the not the speed, but they measures the speed of a period of a wave, speed of a wavelength of a wave. Okay. So, and there's an equation we can relate them on. Okay. So period is basically 1 divided by frequency, and also frequency is basically 1 divided by the period. Okay. So just remember those fundamentals. Then we move on to the next, the wave equation. Okay. So now we learned about frequency, which is measured in hertz. We learned about period, measured in seconds, and we learned about wavelength, which is measured in meters. And the speed, the equation will be the speed of a particular wave is defined as its frequency times the wavelength, or its wavelength divided by the period, okay, in meters per second. And the wave, yep. Since we're going to talk about light in this topic, the speed of light is written down as, say, which is the speed, and which is 3.0 times 10 power of 8 meters per second. This is the speed of light. So, step 1 of this topic will be having those things written down in a formula sheet. Now, also remember this, the relationship between period and wavelength. Okay? So period equals to 1 divided by the frequency, and the frequency is 1 divided by the period.